Hello, ladies and gentlemen. This is Mr. McCabe again. It is Wednesday, September 12th. All right, when you come into class tomorrow, this is the flip book you needed to have created. All right, notice linear functions. I want these titles. I want parent function, function, y-intercept, domain, range, y equals mx plus b, which is your slope-intercept. I need ax plus by equals c, which is your standard form. I need y minus y1 equals m times x minus x1. This is called your point slope form. And I also need scatter plots. We'll leave the rest of the space down here. Now, if you want to make these bigger, that's fine because it'll give you more room to write things. So if you know that you're not a very good drawer or your handwriting's a little too big and you can't draw small, make these a little wider. We got plenty of paper up here that you can copy things down. Okay. I'm going to show you these. I'm not really going to go through detail. So this is function. This is parent function. Here is function. I'm going to blow this up so you can see what to write here. All right, there we go. All right, that's function. So you can draw these things as best you can. Here's y-intercept. Here's y-intercept. So these are some of the things. We'll go over this tomorrow. I'll explain what all these are tomorrow. Domain. Here's what I want you to write for domain. Okay, that means all real numbers. Okay, this means domain is equal to x equals -3. Again, domain is all real numbers. That's that little double R I showed y'all. Range. Range, I want you to write the same graphs, but the range changes for this one and for this one. Okay. Now notice I don't have anything for slope intercept, standard point slope, or scatter plots. We will fill these in together. Or you can fill them in with as much information as you want to. This is going to be yours to help you study for future quizzes and tests. Just to give you a little rundown, these are some of the things that that could go on here. I know it's a lot, but it just kind of shows you how much information you're going to be learning here in the next few days. So, okay, I'm going to go ahead and put up the charts that we covered today. Here we go. All right. Here is B. This was the CDs for the band. Just in case you did not get all the information, I told you I'd put this online. Okay. Here's your defining variables. Here's your equation, your chart or your table, and then of course the graph. Now, not necessarily, you don't have to actually connect these because this was actually discrete data, but you can't sell or make half of a CD. So I'm going to go ahead and flip to the next one. That was from Group B. Here was Group C with the Explorer's Glide. You might want to fill this in on your table. H and T. H is the height of kilometers above the Earth. T is your time in minutes. Your equation is H equals -0.25 T plus 100. All right, that's the rate that the Explorer is descending. Notice that we use change of y over change in x. This is your delta y over delta x. Change in y over change in x in order to get the slope, which is -0.25 over 1. Here's our slope, here's our y-intercept, and we use these two instruments in order to graph. All right. I'm going to go ahead and move on to D, which is the geothermal energy. You can read this on your own, but I think we've already done that. Where the temperature is a function of the depth. All right, so this is another name for y equals. So y equals 35 degrees times each kilometer plus 20 degrees Celsius for our initial starting point. If you notice over here, if we are at 0 degrees depth, 0 kilometers, the temperature is going to be 20 degrees. And notice how as the depth increases, how the temperature increases as well. All right, over here, this is where we graphed it. Remember, start at 0.20, and notice that it increases. So as the depth increases, the temperature is increasing as well. That gives us an initial degree of 20 degrees, and it increases for every depth that we go down. For every kilometer we go down, it increases by 35 degrees. That's our rate. All right, finally, E. Here's our height. In our minutes, this is the hot air balloon problem. So we're going to start at a height of 800 feet. It's going to descend at 20 uh, feet per minute. Notice that that's our delta y, delta x, over delta x. This is our change in y over change in x. That means the height is changing for every minute that it changes. All right, so 0 minutes gives me 800 feet. Notice in 10 minutes it has dropped 200 feet, which gives me a height of 600. It is descending. So as our minutes increase, our altitude or our height also decreases. All right, that concludes basically what we did today. Make sure you're prepared with your flip book tomorrow. Thank you.